Welcome to the K-State Regen Ag Podcast, where we talk all things regenerative agriculture here at Kansas State University, across the state of Kansas and beyond. I'm Nick Detter, your host, and today I'm joined by Doctors Gaurav Jha and Dr. Deepak Joshi of the K-State Agronomy Department to talk about the intersection of regenerative agriculture and digital and precision ag. Thank you guys for joining me today. Gaurav, would you introduce yourself to the audience and tell us a little bit about who you are, what role you play at K-State, and how you got to this position?
Yeah, thank you, Nick. Thanks for having us on the podcast. It's great to talk about precision agriculture and our journeys towards precision agriculture and how it ties to regenerative ag. So before we get on to those discussions, a little bit about myself. My name is Gaurav, and I'm assistant professor in precision agriculture at Kansas State. With a distribution on research and teaching focus. And my lab, Digital Agronomy Research Team, in short, it's called DART, focuses primarily on integrating sensor-based technologies like it's proximal, which is sensors which are very close or in touch with the crops, or with remote sensing sensors which are away from the crops. So we try to integrate and gather or extract as much data from the field. I should rather say more meaningful data from the field, and then we try to convert them into more interpretive solutions for the farmers. My lab primarily focuses on precision water and nutrient management. Those are some key areas. While we do not focus primarily on crop, I feel we need to go wherever with the crops, wherever the problem is, using the technology and solve those out. So that is where my lab primarily focuses on. I do want to highlight on some key areas that allowed me to build my motivation towards both precision agriculture as well as communicating science. So my research primarily started in India. That's where I'm originally from. And my research was focusing on arid areas of India where there was issues of dry conditions leading to saline irrigation water, and how precision agriculture or precision tools and technology can solve those problems. So I worked in India, and then I moved to New Mexico State for my PhD. And that's where I feel that was a very formative phase of my life when I got opportunity to work with the indigenous communities of Navajo Nation. So I felt like there was an issue across the watershed. It's called an animus watershed in the Southwest. So there was contamination that came out of the river, and my role was to use proximal sensing technologies and integrate with geostatistics. In simple terms, integrate maps or maps that would make more sense for agricultural farmers to revert back to the original practices that happened before the mine spill. So I also learned there how to communicate science, because most of the times we speak jargons and we forget that that's not the language the community would understand. So I learned how to communicate science in a language or analogy that people would understand. Again, my lab focuses on tools and technologies here at Kansas State, which are soil-based, canopy-based, and aerial, which is remote sensing and satellite-based solutions. And that phase of my career was formed at University of California in Davis when I was working and my postdoc. And I landed up in California in the worst time, I like to say, because one, it was the worst drought years, the consecutive drought years that California was facing. And then I landed up in a phase where COVID was hitting its peak in California. So both of those things were very challenging. And that's where I learned about sensor technologies as much as I did not before. And that's what I think my program here at Kansas State is phasing out. When I landed in 2023 in Kansas, Kansas was facing up with its consecutive dry season as well. So I got the opportunity to expand and leverage my skills from before and establish my program in that direction.
Well, thank you so much for joining us, and I'm excited to hear about how your research is, particularly for some of our water-limited farmers, sounds like it could be very relevant. So, and Deepak, would you mind introducing yourself and telling us a little bit about your role at K-State and how you got there?
Yeah, thank you so much, Nick. I will start with my introduction actually. So my name is Deepak Joshi, and I'm an assistant professor and precision ag extension specialist. I started at a K-State just a year ago, so I'm still kind of new, and I'm still trying to figure out my plan, my program as well. And before K-State, I was at Arkansas State University. I was working as an assistant professor there just for a year, and I did my grad school from South Dakota State University. So that's where I start my precision ag journey actually. So over in South Dakota, I was working with lots of grower all around the state, especially the soybean and corn grower, and I was helping them to on the on-farm studies using precision ag technologies like how to analyze the yield monitor data and how to use drone data and some satellite data and combine them into the different data analytics modeling like AI, machine learning, and how we can use those data to make the better decision to help the grower to make the decision. And while I was doing my grad school over there, and I started doing the regenerative agriculture as well. Like my PhD work was more focused on the regenerative agriculture. So I was primarily focusing on the cover crop system and how it improve our soil health. And I was trying to measure those benefits of the cover crop. I did some meta-analytic tools as well, and using global data set that are published from all around the world. Like I tried to quantify how much soil carbon is increased by the cover crop, and the main finding was almost 7.3% soil organic carbon was increased due to the cover crop actually. So overall, that main finding was that if we want to sequester the carbon from the atmosphere, I think cover crop can be a very good option from that study actually. And another was we did some field trial as well, and to quantify if the cover crop improved the greenhouse gas sequestration. And the main finding from there was before termination, cover crop store the nitrous oxide emission and increase the reduce the nitrous oxide emission by 33% compared to no cover crop planting. So that was a really another important finding from that my study. And that was my journey back in South Dakota as a grad student. And before that, I grew up in Nepal, where I grew up in a small farm where we grow rice and wheat, especially. And my interest in the precision agriculture was from there because we don't have any technology exist there. We don't have any yield monitor system. We still use the very old design tractor there, but still a lot of people, they still use the animal-based planting tool actually, like an ox. So that's why I feel like we need a technology and we need to start using the new precision ag technology. So that's where I start my journey. So at K-State, I'm working mostly as an extension specialist as well. So my focus are on the extension and outreach related with the digital ag and precision ag. So, and also at the same time, I have been involved on some applied on-farm studies as well. So I've been using a lot of drone data, satellite data, and how to use those on-farm data and to make a better recommendation for the grower at the field scale level. So that's what I've been doing, and also have been involved in a lot of traveling all around the state to distribute the information related with the precision ag, how we can increase the adaptation of these technology in the Kansas state overall.
Yeah, well, that's great. It sounds like we're gonna have a lot of things to talk about. So, but before we get too deep into the details, Gaurav, would you mind for our audience, just in case these are terms they're not as familiar with, defining precision agriculture and digital agriculture?
So, in very simple terms, I would say like when you talk to farmers, they know their field quite like visible. I mean, the variability across the field quite more than what our tools or technologies can tell. Like they have years and years of experiences that can say, hey, like the north side of my farm is probably not giving as much yield as the south side of my farm is. So I feel like every field has some variability that is the foundational concept of precision agriculture. So when there is variability or heterogeneity in soil in any field. And as the crop is growing in those soils, we need to understand how much amount of input is needed to make as close to homogenized production as we could. So in simple terms, precision agriculture is both basically the tools and techniques that we are using in terms of like sensor drones or even just models or ideas or practices that let us quantify the soil metrics, like which could be tied up to soil health or like diversity of the nutrients or like the water efficient or water holding capacity of the soil. So again, it's just how every field generates data and how we can use our management philosophy as well as the tools and technology to use that data in making more informative for farmers to produce crops. I feel that's how I would like to define precision ag. And every person has a totally different approach towards using those technology tools, and that definition differs. So when I teach a class, students come up with very different terminologies or very different understanding of precision ag and its areas.
And would you say digital ag is just a synonym for precision ag, or are there also is there any differences or nuances with that term digital ag?
Yeah, it's used synonymously. Only when I mean, precision agriculture, when we are talking about it, like it's definitely includes the management philosophy, which is tied to digital agriculture as well. When we talk about digital agriculture, it's more integrating the data and making more advanced algorithms, so to make interpretive capabilities of it. So I would say yes, it's more like synonymous to each other, but there's just a fine line of difference when we start dealing with more complex equations and algorithms. We are diving into more data intensive or digital intensive studies there.
Makes sense. Well, Deepak, since you did some of your graduate work on this, I'll give you the first crack at this question. So how do these precision ag tools that Gaurav just kind of laid out for us, how do you see them being beneficial to farmers as they're, starting to pursue some of these regenerative ag practices we're familiar with, like cover crops or no-till or animal integration, any of these regen ag practices that are becoming increasingly popular?
Mhm. Yeah, thank you, Nick, for the question. Actually, I think Gaurav, he explained very well on the precision ag. I think I echo with all of his concept. Actually, that's a really comprehensive definition of the precision ag. So I think on the regenerative application of precision ag tool on the regenerative ag, I think this tool can help to measure the benefit of the regenerative agriculture. For example, I've been working on a regenerative ag project here in Kansas right now, and we have a cover crop treatment, we have a tillage treatment, crop rotation treatment, and smart fertilizer treatment. And the main idea is the application of the precision ag tool, how we can use these tools to measure the benefit of all these management practices. So what I have seen is to measure these benefits, usually we have to wait until the harvest actually. But now with these advanced tools, we can measure the in-season benefit as well, like crop growth in the real time. So we can fly the drone and get the information about the crop growth at the real time as well. So these have been very useful. And so far, we on one of our experiment, I found like if we plant the cover crop at the early growth stage, we don't see much different on the cover crop and no cover crop plot on the corn health. But later growth stage, after the termination, like 3 months after the cover crop termination, when we compare the corn health, I found the plot which had the cover crop improved the NDVI value. That means those cover crop plot corn had a better crop health during the later growth stage, and it makes sense as well. After the 3 month after, there was a much decomposition, and there was a more soil microbes there, more moisture retention there, and the corn had a better health. So these tools are really beneficial nowadays to do the real-time monitoring of the crops under different management practice, like especially the regenerative management practices.
Yeah, that's great. I have a follow-up question on that. So do you see the drones being more of a tool for researchers, or do you see drone and drone technology also being more incorporated by farmers in their operations?
Yeah, thank you, Nick, for this question. Actually, I've been working with a lot of grower in Kansas right now. I travel all around the state and meet a lot of grower every week, actually. And I always had a chance to interact with a grower as well. And I have seen so many grower, they do have their own drone as well. So they have a drone. These technology are very efficient because they want to use the technology, because if you have to scout or check your field by yourself, you have to walk around big
Yeah.
field all day. Now the technology, this technology, you can finish scouting the field in 30 minutes. So it's a very time efficient, and with the new advancement in the tool, and it's a very easy to process all these information as well. So it's a lot of improvement in the technology. So I think farmers are using this technology in Kansas, especially the drone technology. But still, we need to improve some of the aspect on how to process these information, how to help them to make the better decision. So
Yeah, no, that sounds like exciting stuff. Well, I'll turn it over to you, Gaurav. What's some of the research and tools that you've been involved with that you feel like have an impact in this regenerative ag space?
Yeah. Great question. I think, when I think about regenerative agriculture and digital agriculture, a lot of people are working in this direction all across the nation and even like globally, I would say. So again, these are not very different areas of science or agricultural research. I see it more complementary, and like those two angles could be married together. And most of the things that Deepak highlighted does tie to the data that is coming out of the field and the changes that is happening over space and time in the field itself. So some of the projects that I'm working on right now is one of the projects is funded by National Science Foundation, which is it's called MICRA, or Microbial Innovations for Climate Resilient Agriculture. So in that study, what we are looking upon is so soil has a lot of microbes, like millions and millions of microbes. So we are targeting on soil bacteria, which there's one form of bacterial strain, which is Bacillus subtilis, and there's a wild strain that enhances the water holding capacity. So this strain, there's a strain that has the capability of increasing the water holding capacity of the soil. So what we are looking at is like how this microbe, the inherent or the existing microbial communities in the soil, is increasing the water retention in the soil. How could be water held for longer time or in different soil types? So we are doing like lab studies, greenhouse studies, as well as like translating into the field studies. And we are combining with like different amendments. Like one of the amendments is biochar, which has more hydrophilic property or like water loving properties for the soil. So we are integrating these just to understand uh, extracting all the data from the study. So we are using sensors from like the meter group, as well as we are using some evapotranspiration model. Again, when I say evapotranspiration in simple terms, it's the loss of water that plant releases into the atmosphere. So we are trying to sense those capabilities in terms of our like sensors that we have in our lab. So some of the sensors that we advanced to that and like apply towards learning regenerative agriculture, and also this applies to the project in North Agronomy Farm on regenerative agriculture, is we have used drones. Drones have cameras that could see like red, green, blue, as well as ranges that that our visible eyes cannot see. So it's multispectral, like near infrared, red edge. These are the other bands that could be seen. So we use those bands like some additional set of eyes for the drone to look into what are hidden and we are not seeing. Like it could be early stress in the crop driven towards the soil health parameters of the field. So we have collected some data just with multispectral and then hyperspectral data. When I say hyperspectral, it's more like when you say like 5 bands and like red, green, blue, near infrared, and red edge, and you give steroids to them, it splits into many, many bands. So basically, we are trying to split that into more like further like refining of the colors or spectra that we usually see, and then just identify more appropriate properties that for a farmer, it might be like very, very late in the season to define those deficiencies in the soil. but based on our like data and based upon our research, we can analyze it early in the season. So we are trying to do those. A lot of projects that my lab primarily focuses on is related to water retention, and everything ties to the soil texture, soil properties, or the soil health that retains moisture in it. So we are installing sensors in the fields. Some of the common sensors, like we install our, yes, soil moisture sensors are those, but we also use some radar sensors to kind of sense those and identify the properties that vary across the field.
Yeah, that's great. I'm going to ask you a follow-up question as well. So, in the western part of the state, we definitely have a more water limited environment, even some challenges when it comes to irrigation capacity. Are you seeing adoption of those types of sensors or those kind of technologies from growers out in western Kansas, or how is that kind of playing out your research, particularly in some of the drier parts of the state or relating to irrigation efficiency?
Yeah, I think that's an excellent question and a very right time to ask the questions about. I mean, we are seeing good rain this year, right? Like, so there is also, it's not just about when we talk about sensors, it's not just we are talking about drought, but we are talking about a resilient system. Some years we might have very good moisture, and that's like a non-stressor years for us. Sometimes there is a stress conditions. So I think the biggest question for us is like under stress conditions and non-stress conditions, the technologies that we are promoting are like worth for growers to adopt. So that is being answered by, so we have a new project by USDA Sustainable Ag Systems. That project, we are adopting 15 different producers in the Southwest Kansas, just understanding how these producers, depending upon different crop types, different soil types, and different, environment, basically from north to south of like the irrigated regions of Kansas, how would they adopt these technologies? So I think I would be in more better position for like telling about adoption after we have done some research on those. There is also a like survey part from an ag economist on team, so we will learn more. And I'm sure like Deepak can highlight more on adoption as he's working on across the state with some of the farmers like who are already adopting these technologies.
Yeah, well, it sounds like he's handed it off to you, Deepak. Do you want to highlight any of the adoption you've seen, or I guess just, now that you're in the extension field, what are the questions you're getting from growers around these technologies? What are they most interested in? What are they most excited about? Where are they seeing opportunities and challenges?
Mhm. Thanks, Nick, and thank you, Gaurav. So yeah, I've been traveling all around the state. Though I've been here, just this is my first season. But still, I think I already get the kind of general idea about the need on the precision ag side of the state. I think there is a huge need on the technologies, huge interest as well, not only need, there is a huge interest on the precision ag technologies, specifically the drone, like not only the mapping drone now, grower and youth, they are very interested on the spray operational drone, like a spray drone, seeding drone, and these business are increasing here in Kansas very rapidly, actually. These drone technology, especially on the operational type spray, these are increasing a lot. And also, there is a new on the Western Kansas, especially on the water management side, and how these regenerative ag practice can be incorporated to maintain the water efficient and also to improve the soil health. Um, as well as to increase the crop yield as well. There is a huge need of these regenerative ag practices on the Western Kansas because water is a big challenge over there, and at the same time we have a climatic issues like extreme drought, extreme wet, and at the same time Western Kansas is windy. There is a huge wind erosion loss as well. So these management practice, regenerative management practice, can help to solve those issues. And lastly, I want to mention also not only the precision ag technologies and tool, and there is a huge interest on the like a new data analytic tool like AI technology. So there is a huge interest all around the state on this aspect of the regenerative ag and precision agriculture.
And how do you see the AI? How is that going to fit into the future of agriculture? Do you have any thoughts on that? Either one of you.
Yeah, I think there is a lot of growers already using these technology. Like we have for example, John Deere, they have a see and spray. That's AI-based technology. People are using that, and people want to use more, especially on the spray drone side as well. They want to do the spot target application using the drone, and so that it can detect the weed at the real time using the AI model, and also at the same time it can spray as well. So there is a huge interest, and there is a huge concern as well on the AI, like if AI gonna solve all the issue or not. So that's another challenge. So trustability is another issue. So I think growers are interested, and people will use these technology more. And once we have a more improvement on these technologies, so there is a huge interest and on from the grower side.
Well, it sounds like we'll have a lot to check in with you guys going forward. I mean, this is definitely a field where it seems like things change pretty rapidly, and I'm excited to see where it all goes. To wrap it up, we always like to end it on a high note here at the K-State Regenerative Agriculture Podcast. And so I'll start with you, Gaurav. Just tell us one thing you're really excited about in your work right now, whether that's with students and teaching, or with your research, or things you see happening in the field, or even here at Kansas State. What's just something that's got you looking up and happy about right now in the field?
Yeah, yeah. And I think I'll connect a little bit to the AI piece that Deepak highlighted. We were working on the trustworthy AI aspects of there's a publication that we were working on trustworthy AI. Some of these technologies that are coming into play in precision agriculture, it's not new. We have been talking about yield monitors. We have been talking about soil maps for maybe like 20, 30 years. It's not a new concept. The only issue is like when the data is coming out, like we see a lot of yield maps, but the question is that calibrated enough? Is that like, was the person or the farmer collecting the yield monitor data? Did they calibrate those or not? So I all like often get students who are coming from the farm background who are very much aware about these technologies. When they come to the class, they have those fundamental ideas of what are different data layers or the like yield maps, soil maps. Grid soil sampling is not at all a new concept. That's been there forever. So when they come into the class, what like our goal, and particularly when we work with students or like people coming from the farming communities, we try to like connect those technology to a purpose, like something that could be used for making decisions. So something that excites me about my role here is like when I teach classes, and then we last year and earlier this year we had like Smart Farm Challenge workshop and Farm Challenge course where we were trying to work out in the field, and students was able to collect their own data, analyze their own soil data, and actually see how management decisions play out in the field. I also try to make teams of students who would act as a precision ag consulting company and make prescriptions. So when those prescription works and like those data layers which they were lost into a huge pile of data, finally when they're making sense out of it in terms of prescriptions, I do see a spark. That's the aha moment for them and for me in the class. And that's when they realize like precision ag is not just about the technology piece, but it's all about like regenerative agriculture or like
Mm.
stewardship of like agriculture that's happening in the field. So I think that is the moment when I see, I mean, their approach could be quantified and like they're visually showing the maps with low, medium, and high zones in like colored palettes that they would be willing to give out to a farmer and could be applied towards learning. So I feel the learning piece is kind of what excites me about precision agriculture and when it's being translated from students, and probably they would be applying it further in their fields.
Yeah, that is really exciting. It sounds like some of the future leaders of regenerative agriculture and precision agriculture are being shaped right here at Kansas State right now. So thank you for your work on that. Same question to you, Deepak. What's something that's exciting you? Just anything in your work right now?
Thanks, Nick. Yeah, though I'm a kind of still a new, I guess, but I'm so excited about the Kansas, especially on the precision ag and regenerative ag. While I was traveling all around the state, I found our farmer, they are really interested on the improving soil health, improving the crop health, improving our environment around. Like they want to improve the soil air health, and a lot of farmer, they already adapting the regenerative agriculture practices as well. and at the same time, they also have the interest on the precision ag tools, and they want to use all these and combine together and in the future as well. So as a precision ag specialist from the K-State, I'm also very excited to collaborate with each of the grower in the Kansas to work together on these practices. And I'll be happy to collaborate with all the grower, and also happy to how we can help from the K-State to increase the adaptation all around the Kansas on the regenerative agriculture side.
Yeah, I guess just in that same vein, if a grower did want to get in touch with you, or if somebody was listening to this and they had more questions, where would you recommend them to go?
Yeah, they can reach out to me as well. I think they they can find my information from the K-State Agronomy Department website as well. My email address as well, if you want to put somewhere on the podcast. So I would be happy to provide you my additional information as well.
We will do that. We'll include that in our show notes. Well, I just want to thank you both so much for joining us. I think there's a lot of exciting things happening in this space and in this field. I really think that, this is a transformative area for how, we can take Regen Ag and really make it applicable and usable, at a really at the farm level. I think it's that technology side that can really be transformative. So thank you both again, and we just want to thank everyone who joined us for another episode of the K-State Regen Ag Podcast, and we'll see you next time.
Oh, give me a home where the buffalo roam, where the deer and the antelope play, where seldom is heard a discouraging word, and the skies are not cloudy all day. Home, home on the range, where the deer and the antelope play, where seldom is heard a discouraging word, and the skies are not cloudy all day.